Welcome. Thanks again for tuning in. Today we're covering the properties of exponents. And for some reason, this is a real trouble spot for a lot of students. It's as if the operational use of exponents is learned in high school, and students learn it well enough to do well on tests and that sort of thing, but it seems to go into short-term memory because it's just real trouble for a lot of students when they get to the SAT. For some reason, a lot of students have trouble with this, and it's as if they just forget. So let's get right into it. So the properties of exponents, let's begin with the product rule. When multiplying exponent numbers with the same base, just add the exponents. This is the biggest trouble spot of all. Students forget that you just need to add those exponents. So for example, a to the power of m times a to the power of n equals a to the power of m plus n, and where students go wrong is they multiply those exponents. They would multiply m times n, and that's just incorrect. So let's look at an example. So if you have 3 squared times 3 cubed, you're just going to add those exponents, and that would be equal to the 3 to the power of 5. So just break it down. If you forget this or you want to work it out, just do this on the test. So 3 squared, of course, is 3 times 3. 3 cubed is 3 times 3 times 3. So that clearly is 3 to the power of 5. All right, so when you're multiplying numbers with exponents, just make sure you add those exponents. But again, the numbers have to be the same base, the same base number. Okay, that's the product rule. The quotient rule, when you're dividing, here we have a to the power of m over or divided by a to the power of n, in which case you would subtract the exponents, a to the power of m minus n. So let's see why this works. 5 to the power of 5 divided by 5 to the power of 3. Now if you just do it out, it would look like this. Now these first set of 5s cancel, and so you're left with 5 squared. Okay, next up is the power rule. And this is where you do multiply exponents. It would look like this. X to the power of a, in parentheses, all to the power of b, equals x to the power of a times b. So for example, if you have had x squared, in parentheses, to the power of 4, that would be the same as x to the power of 2 times 4, or x to the power of 8. And if you map it out or draw it out, it looks like this. It's x squared 4 times. Clearly x to the power of 8. The zero exponent rule is kind of an odd duck. You probably won't see this anywhere, but you could come across it on the SAT or the ACT. And it's just any number to the power of 0 equals 1. The negative exponents rule suggests that if you have a negative exponent, a to the power of negative b is the same as a to the power of negative b over 1. So if you inverse those, use the multiplicative inverse, you can change that negative exponent to a positive. Okay, so for example, if you have 5 to the power of negative 2, you want to change this exponent to a positive because it's probably in use or it's in play when you're trying to simplify an equation or solve an equation. And so it's just going to be easier to turn this into a positive. So again, what you do is 5 to the power of negative 2 is the same as 5 to the power of negative 2 over 1. Inverse these and change it to a positive. That concludes this section on exponents. Definitely review these. Definitely know these if you're preparing for the SAT or the ACT. You'll definitely see problems using these. Thanks.